In the previous video, you learned that phenol was a benzene ring with an alcohol group. But rest assured, phenol is nothing like an alcohol. In fact, there are some key differences between phenol and other alcohols in terms of their physical and chemical properties. One difference is alcohols can dissolve in water, and phenols cannot. Remember, in order for a substance to dissolve in a solvent, the solvent particles must be able to form intermolecular forces with the solute particles. Furthermore, the sum of the intermolecular forces between the solvent and solute particles must be stronger than the sum of intermolecular forces between the solute particles alone. It is this condition that gives the appearance of a solute disintegrating or disappearing into oblivion, as the solvent particles break the solute into its individual particles. In the case of alcohols, the polar OH bond has the ability to form strong hydrogen bonds with water molecules. But don't forget the limitation to this property. Alcohols with an alkyl chain less than 5 carbons long will be miscible in water at room temperature. Alcohols with an alkyl chain greater than 5 carbons long will be immiscible in water at room temperature. In fact, a 10-carbon alcohol like decanol can only have 0.37 grams dissolved in 100 milliliters at 20 degrees Celsius, whereas butanol, a 4-carbon alcohol, can have 7.7 grams dissolved in the very same volume of water at the same temperature. If you wanted to dissolve more decanol per 100 milliliters of water, you would need to increase the temperature of the solution. The same is true for phenol, where if you were given 100 milliliters of water at room temperature, you would only be able to dissolve 0.084 grams of phenol. The reason for this is that although the OH group in phenol can allow it to form hydrogen bonds with water molecules, the high number of carbons within the benzene ring and little to no branching within the benzene ring increases the number of contact points for London forces to occur, therefore requiring more energy needed to overcome these intermolecular forces. While you are only responsible for knowing one difference between phenol and alcohol in terms of their physical properties, you need to be aware of two chemical properties that sets these two classes of compounds apart. The chemical difference is that phenols can undergo proton dissociation, while alcohols cannot. Although phenol does not dissolve well in water, it does transfer protons onto water molecules quite well, consequently turning into a negatively charged phenoxide ion and making water slightly acidic. The reason why phenols prefer to donate their protons is because phenol molecules are more stable when they are a phenoxide. When the oxygen in phenol is bonded to the hydrogen, it is surrounded by 4 areas of electron density, which repel each other as far away as possible, causing the bond angle here to be 104.5 degrees, and the bond angle here between the lone pair, oxygen, and carbon 1 of this benzene to be well over 109.5 degrees. as the two lone pairs around oxygen repels the bonding pairs much closer together. And finally, the bond angle between the benzene p orbital, carbon, and the oxygen is 90 degrees. While it appears that the oxygen has a p orbital parallel with the p orbital in benzene, these orbitals are actually slightly non-aligned or out of sync, which is difficult to show in this 2D picture. But when the oxygen in phenol undergoes proton dissociation, there is a change in electronic and hence atomic orbital arrangement. When phenol becomes a phenoxide, oxygen's electronic geometry becomes trigonal planar, while oxygen's molecular geometry appears linear. And as a result, the oxygen in phenoxide is now surrounded by 3 areas of electron density, which repel each other as far away possible. This new electronic geometry allows a p orbital to join the pi bond within benzene and thus acquire stability through the pi system of electrons. The second chemical difference between phenol and alcohol is that phenols can react with alkali, alcohols cannot. The reason why is because phenols are weakly acidic, alcohols are not. The reason why phenols are more acidic than alcohols is because phenols can lose their protons much easier than an alcohol. The general equation for the reaction between a phenol and an alkali is as follows. An example of such a reaction includes phenol reacting with sodium hydroxide to form sodium phenoxide and water. And while you've been told that phenol, as a weak acid, is able to acidify water and neutralize an alkali, phenols are not able to fully neutralize metal carbonate bases because phenols are not strong enough acids to do so.